On December 9th, NASA tracked a near-Earth asteroid known as 2025 XM as it passed safely by our planet. The object traveled at high speed and came within a distance comparable to the Moon's orbit, which naturally drew attention and news coverage. However, NASA confirmed early on that the asteroid posed no risk to Earth and fell well below the size required to be considered hazardous. Events like this are part of routine monitoring carried out under planetary defense programs. In this video, we will take a closer look at what was observed, why scientists track asteroids like this, and what it tells us about Earth's safety in space. Let's get started. Asteroid 2025 XM was identified through NASA's continuous survey of near-Earth space, a process that relies on automated telescopes and orbital analysis to detect moving objects and calculate their trajectories. Once detected, the asteroid's path was quickly refined, confirming that it would pass Earth safely without any risk of impact. The flyby occurred on December 9th, with the asteroid passing at a distance of approximately 295,000 miles. This places it at a range comparable to the average distance between Earth and the Moon. While that proximity may sound close in everyday terms, astronomers consider it well within a safe and predictable range. Objects frequently pass through this region of space, and such encounters are expected as observational coverage improves. Size estimates placed 2025 XM at around 84 feet in diameter, roughly comparable to a commercial airplane. This measurement is a key factor in assessing potential risk. Under NASA's classification system, an asteroid is considered potentially hazardous only if it is significantly larger, generally over 150 meters in diameter, and passes much closer to Earth. 2025 XM meets neither of these criteria. Reports also noted the asteroid's speed, measured at roughly 9,753 miles per hour relative to Earth. While this number may appear striking, it is typical for near-Earth objects. Asteroids often travel at high velocities depending on their orbit and relative motion, and speed alone does not indicate danger. Risk assessments focus primarily on trajectory, size, and mass, rather than speed in isolation. By the time the asteroid appeared in public reports, its orbit had already been confirmed through multiple observations. This meant there was little uncertainty about its path long before it reached its closest point to Earth. The tracking of 2025 XM was therefore not an emergency response, but part of routine, ongoing monitoring. During the same time frame, NASA also tracked other asteroids, including 2019 XN3 and 1999 SF10, both of which passed Earth at even greater distances. These concurrent flybys highlight the fact that near-Earth space is dynamic and continuously populated by small objects moving through predictable paths. Although 2025 XM posed no threat, its close approach still contributes valuable data. Each tracked flyby allows scientists to test the accuracy of orbital predictions by comparing observed positions with calculated models. When predictions and observations align closely, it confirms the reliability of current tracking systems. When small differences appear, they help refine future calculations. This process underpins modern planetary defense, which is designed around preparation rather than reaction. The primary objective is to ensure that any asteroid capable of causing regional or global damage is detected far in advance, allowing time for careful analysis and response planning. Objects like 2025 XM also help scientists better understand the broader near-Earth asteroid population. Smaller asteroids are far more numerous than large ones, and tracking them improves statistical models that estimate how many objects exist, how often Earth encounters them, and how their orbits change over time. Beyond orbital mechanics, astronomers are interested in the physical properties of these bodies. Even without spacecraft missions, researchers can infer details such as rotation rate, surface texture, and reflectivity by studying how an asteroid's brightness changes as it moves and spins. These measurements contribute to a growing database used to inform future research and potential mitigation strategies. Clear classification is another important outcome. The term potentially hazardous asteroid has a precise scientific definition, but it is often misunderstood in public discussions. Routine reporting on harmless flybys like 2025 XM helps demonstrate how risk assessment is grounded in measurable criteria rather than speculation. As detection capabilities expand, more asteroids are being identified and cataloged. This does not indicate that Earth is facing increasing danger, but rather that monitoring systems are becoming more comprehensive and sensitive. The flyby of 2025 XM reinforces confidence in current near-Earth object monitoring systems. Objects of this size and distance are detected early, tracked accurately, and evaluated with a high degree of certainty. This capability is central to planetary defense efforts. Looking ahead, the number of reported asteroid flybys is expected to increase as new telescopes and improved data analysis tools come online. Enhanced detection allows scientists to identify smaller objects at greater distances, increasing visibility into Earth's cosmic environment. While this may lead to more frequent headlines, it reflects improved awareness rather than heightened risk. Planetary defense is also becoming more collaborative. Space agencies around the world share observational data, ensuring consistent tracking and assessment across different systems. This international coordination strengthens the overall reliability of asteroid monitoring. At the same time, research into mitigation strategies continues. Although no action is required for asteroids like 2025 XM, scientists are studying techniques such as trajectory alteration and impact prevention. These efforts rely on years of observational data collected from routine flybys and long-term surveys. One of the most important aspects of these events is context. Individual figures, such as speed, size, or distance, can appear alarming when viewed alone. When interpreted within a scientific framework, they often describe normal and well-understood behavior. As astronomers continue to catalog near-Earth objects, the focus remains on early detection, accurate classification, and clear communication. The goal is not to predict dramatic events, but to ensure that any genuine threat is identified with sufficient time to respond thoughtfully and effectively. Asteroid 2025 XM was never a threat to Earth, but its flyby shows how effectively near-Earth space is monitored today. Routine detection and precise tracking allow scientists to separate harmless objects from real risks. As observation improves, events like this simply confirm that planetary defense systems are doing their job.